Alright, so with quadratics, there were three things that could happen. And that's what we were talking about earlier. Like, it could look like that, which meant there were two imaginary solutions because it didn't cross the x-axis. It could look like this, which meant there were two real solutions because it crosses the x-axis twice. It also could look like this, crossing it once. That even though that's just one real solution, we call that two solutions because it's a double root because of the way that it looks. Cubic functions add a root. So with quadratics, the highest power is a 2, so that's why there's 2 of everything. When you have cubic functions, they have a degree of 3. The highest power is 3, so that means there has to be 3 of everything. And so the possibilities is there's going to be 3 solutions. It could be 3 zeros. It could cross the x-axis 3 times. It could cross the x-axis 2 times, and one of the times look like that, and that counts as 2 solutions. It might only cross the x-axis once. If it crosses the x-axis once, that means the other 2 solutions are imaginary. Okay? And so knowing what type of solutions there are will help you figure out what it is that we need to do. So, just so you know, if it looks like a quadratic at a point, that's whenever there's a double root. So, looking like that makes the double root. Looks like a cubic, so maybe like that would be the cubic, but right here is the place that there would be a double root, because it kind of just sits there, okay? When it says looks like a cubic, it's kind of a weird thing, but it might look like this right here. Like it kind of goes through it and levels off and goes up. That's 3 solutions. So we call that a triple root. And if you can't see 3 solutions, that means there's going to be 2 imaginary solutions. So let's just look at these graphs below here. There's a whole lot of graphs. What we're doing with these graphs is we're just talking about what kind of solutions there's going to be, because if you can understand the kind of solutions, solving the problems will not be that difficult. Okay? So this first problem, notice there's 2 times it crosses the x-axis. Okay? This first one's just a regular old solution. What's going on with this one? It's a double root. So on this one, there's 1 real, and there's 1 that's a double root. That makes 3 solutions, because the double root counts as 2 of them. Okay, look at this one right here. That one crosses the x-axis there and there. So what's going on with this one? 1 real. That's a real one too. But it has a double root. So that makes 3. Okay? Let's look at this one. This one only crosses the x-axis once. That means there's 1 real. And we have to have 3 solutions because we're talking about cubic. What that means is that the other 2 are imaginary. And this is the ones that we're going to be trying to solve today. The ones that have imaginary solutions, that's the ones that we're having to work with today. Okay? If they have real solutions and double roots, we're going to get our answers from Desmos. Alright, this one here. It crosses the x-axis 3 times. That's 3 real solutions. We're good. Okay? If it crosses the x-axis twice or 3 times, like these right here, you're just going to get your answer from Desmos and be done. But if it looks like this, where there's some imaginary, that's where we're going to be solving today. Alright, on the next one. This is this weird one. It only crosses once. But because it kind of flattens out and then goes back up, this is 1 real, but it's a triple root. And because of that triple root, that means that real solution is the only solution. Excuse me. This one right here is really, really similar. It's just moved over. Still, it's only one real solution, but it's a triple root. Sometimes they call that a multiplicity of 3. If you hear the word multiplicity, multiplicity is how many times it touches the x-axis. If it's a double root, multiplicity would be 2. If it's a triple root, multiplicity would be 3. That's kind of different. Alright, on the next one. This one crosses the x-axis 3 times. We're good. This is 3 real solutions. Okay, look at the last one. Crosses x-axis once. We got 1 real solution. It's not a double root. It's not a triple root. So what are the other 2 solutions? Imaginary. Okay, look at these last 4 real quick. Go through and decide what kind of solutions that you see on those real quick. So as you're looking at these, you first have to figure out what kind of function you have. You have to figure out, do I have a squared, do I have a cubed, or do I have a fourth one? Because that tells me how many zeros to look for. And all of these, I told you it was cubic, and that meant the highest power was 3. But here's some more, and I know the graphs are kind of light, but I think we can still look at it. These, I'm telling you, are quartic, or, yeah, I think all of them are quartic. They might be more than a quartic, I'm not sure. But we'll look at how many zeros they have, and that will tell us whether it's quartic or not. That'll tell us how many, what the highest power is. So let's look at this first one. Again, it's light, but let's look at how many times it crosses the x-axis. 1, 2, 3, 4. Are there any double roots or triple roots or anything weird? No. So what it looks like is the highest power on this one is 4, so it looks like there's 4 real zeros. Okay, on this next one, there's 1 here, there's 1 here. How many zeros does that one count? This one's a double root. So it counts as 2 zeros. So it looks like we've got 2 zeros and 1 real that's a double root. That counts as 4, so the highest power on that one would have been a 4 if we looked at it. Okay, let's look at this next one. There's this one, there's this one, and there's this one. This one is a double root, multiplicity of 2. This one is a triple root. That's kind of a weird one because it like flattens out there. So there's 2, 3, 4, 5, 6. The highest power on this one would have been 6. Just because of how many zeros there are. Okay, and look at the last one. There's that one, and that one. So there's 2 that are just regular old real, and then there's this one here that's a double root. So what would the highest power be on this one? 4. So when you're looking at the graphs help me figure out how many zeros there are. There wasn't any imaginaries on these, but I'll show you in just a minute how you can look at them and tell some imaginary solutions. So the process is down here, and we'll do the problems on the back. But the first thing you do is you graph the function in Desmos. And you look to see how many zeros you're supposed to have based on the highest power. And when you graph it, if it has the number of zeros it's supposed to, then you're done. Okay? If it doesn't, you're going to write down those zeros, and you're going to use those zeros and use synthetic division to divide. When you divide, you're going to get a remainder of 0, and then you do the quadratic formula to find the rest of the zeros. Okay? I'll show you what that means when we get there. Number 3 is the trickiest, and if it shows 2 of the zeros, then you're going to have to divide twice to get down to a quadratic. Okay? And I'll show you that too. Alright, so let's look at some problems. Let's graph number 1. Okay, so we have number 1 graph. Click on the zeros. Notice that the highest power is 3, so I need 3 zeros. The graph gives me 3 zeros, -1, 1, and 2. That means I'm finished on number 1. I don't have to do anything else because the graph gave me how many zeros I needed. Okay? Alright, let's graph the next one. X to the third minus 3x squared plus x plus 5. Alright, I only have 1 zero there. Okay? The highest power is 3, so I have to have 3 zeros. There's only one real one on Desmos. That means the other 2 are imaginary, and the other 2 is what I have to find. Okay? And this will show you the process. So what you do, our real zero is -1. You take the 0 and you put it in the box, and you divide using synthetic division. So that you take the coefficients up here, 1, -3, 1, and 5. Bring down the 1, multiply and add, multiply and add, multiply and add. When you have one real solution and 2 imaginary, and when you divide, you should get a remainder of 0. If you don't get a remainder of 0, then you either divided wrong or you put the wrong 0 in there or something. Okay? When you divide and you started with a cubic, our answers are quadratic, so this is the A and the B and the C that you use in the quadratic formula to figure out the rest of the answer. So it's kind of combining what we've been doing with dividing and then doing the quadratic formula. So we're going to do the quadratic formula now. -b plus or minus square root b squared minus 4ac over 2a. Alright, do like we've done before. Put the 4 squared minus 4 times 1 times 5. Figure out what that is. -4. Alright, I know what the square root of 4 is. It's 2. And then I'm going to put an I with it. And then last step, divide everything by 2. And then that's my answer. So because we have 2 zeros, and because we're supposed to have 4, we're going to divide twice. So we start with -1, or 1. It really doesn't matter which one you start with. Put up all your numbers. Notice we're missing the x squared term, so we're going to put a 0 right there. Okay, we're going to divide. Got a remainder of 0, so that's good. And then what you do is you take the other 0 that you haven't used yet, and you're going to divide again. But the numbers that you're going to put here are the numbers that you got when you divided, without the remainder. So you're going to put these numbers, and then you're going to divide. And after you divide twice like that, that will give you your A, B, and C to do the quadratic formula to find the imaginary numbers. And then so if I do the quadratic formula, I'll have -b plus or minus square root b squared minus 4ac over 2a. If I work that out, I think that's a -3 if I did that correctly in my head. And then I'm going to make that be an I. And then